Good morning. Today we are working on PO61. It is another PO. You'll notice this unit has a lot of POs. It is all POs.
What?
It really is. So we spent an extra day on the first objective because these are that important. Half of the pages I got turned in at the end of the day yesterday still had mistakes on them. We need to pay attention to these small little details or we get our answers wrong. That's why we spent an extra day yesterday, so we can make sure we are doing them correctly, and we can make sure that as we build on it, we are paying attention to minus means negative. How do I subtract from a negative number? Which way do I go? Do I multiply through that parentheses all the way? People are still making those simple mistakes even after going through every step again. Paying attention to our small details, paying attention to the teacher when she's talking, and not distracting others is the big key thing to do when we have all these PO units. So I can solve multi-step equations. So solving a multi-step equation means an equation with more than two steps. When we were doing two-step equations, and I was saying, remember we're doing SADMERP, you subtracted or add first, and then you multiply or divide, write out your steps, and people still fought me on that and didn't want to write the steps out because I can do it in my head. Sometimes we did it correctly, sometimes we didn't. Multi-step equations, you have to write out the steps. I've been telling us, I am preparing you for the harder math. I'm trying to set us up to be the most successful. So when I'm saying, hey, we had to spend an extra day on PO60 because people were missing those small little details and they're not writing it out, thinking it through, it's going to get more complicated as this unit goes on. These are all POs. You must pass them because, hey, this all goes into algebra. You have to have this mastered for next year. So I do not want people working ahead, thinking, oh, I know what I'm doing, because I actually have a job and a purpose up here. I'm trying to teach us, so there should be nobody trying to work ahead at all. Especially after seeing the pages from yesterday and all the mistakes people were still making. We have to pay attention in class. We have to take our time and not rush. And guess what, friends? We might have homework. There's nothing wrong with homework. Get used to it. Next year, your math class is only 45 minutes. This year, it's an hour. You do not have as much time next year to do the math work in class and to ask those questions in class. Get used to having homework. Do not rush through it and just slop down some answers at the bottom because we don't want homework. That is not how we learn. And when we rush, we make mistakes. We learned yesterday how detail-oriented this math is. You have to pay attention. You cannot rush. I want everybody to move on to algebra next year, but you have to master these objectives. Damien.
Why is the math class next year 45 minutes?
Because that's how the 7th, 8th grade schedule is. Every class is 45 minutes. I usually spend half an hour on religion and an hour on math. You get 45 minutes of religion, 45 minutes of math. Mm-hmm. Okay. So it'll be even because Mr. Boyle teaches religion, Mr. Schultz teaches math. So I have wiggle room. Sometimes I give us more time in religion and we only get the 45 minutes in math. It all depends on my lessons. I have an hour and a half to work with. Mr. Schultz only has 45 minutes.
And they have to switch a lot more.
Yes, and they're switching more because of that. So they're switching more with the math and religion, and it's language arts, or you have a lit class with your homeroom teacher, and you have Miss Spiel teaching the grammar stuff. Claire? Okay, you can retake pre-algebra next year. Remember on our summary sheets, it says cumulative course objective percentage, 80% needed to pass the course. So if you don't have 80% of all the objectives passed, you'll either have to do summer school or retake pre-algebra. If you don't master every power objective, that is a must. Power objectives you must pass. If you don't pass every power objective, you will do summer school with Mr. Schultz or retake pre-algebra. You have to, we're not going to pass somebody on to algebra who's not prepared for it. We want you to be successful. If you need to relearn stuff, there's nothing wrong with relearning, right? That's why we do retakes. Sometimes we need to spend a little more time on it. So there's absolutely nothing wrong with retaking stuff, retaking objectives, retaking the class. If you are struggling, we don't want you to struggle next year and then struggle the year after. That's not fair to you. That's not how you learn. So we want you to be in the class that's right for you. So you have to put in the effort. I can't move you up to algebra if you don't understand the pre-algebra stuff.
I get like, I'm only missing one, and then like as soon as I can go, and I know how to do it, but I didn't get enough time to do the retaking. Can I just like go to the algebra, or can I go to algebra, or do I have to stay in algebra?
Remember I said you could do the summer school. If it's just one, it would just be one day of having to go to Mr. Schultz. It wouldn't be the whole summer.
That's me. I thought I do every summer.
Some people do tutoring in the summer once a week, once a month. They set up different stuff. So if you need to go to relearn one objective, you're not going to spend the whole summer on one objective.
Oh,
sorry. I thought we understood how the summer stuff works. Okay, so yes, it's not like the movie. No. Oh, but I did put a little fear of God in you, didn't I? You would have to do tutoring for as much as you need. Okay, so if you have a lot that you need to master and relearn, then it would be for more of the summer. If it's just one, it would probably just be one day.
Probably.
Well, it depends on how, I don't know how easy it's going to be for you to pick it up. It's until you master it. I can't say it's a given. Yes.
Like in the movies, they have, when you think of summer school in the summertime, like they go every single day.
Yes.
Like,
So we're not going to focus on that because we only have half an hour of class left. So let's look at PO61. There are 3 concepts. Oh, and I hear talking. I thought I was very clear that we need to focus and pay attention on these power objectives, Jude. There are 3 concepts we are going to focus on that make an equation multi-step. Combining like terms, what we were just doing that last objective. Combining those like terms, the distributive property, and in PO22 when we had variables on both sides. How we do the SADMERP to get it to work out. So, combining like terms, our goal is to simplify the equation by combining like terms. So what we've been trying to master from the last objective. By combining like terms. Lakeley.
instead of PO22, no, ours is just PO62.
Okay. So this is an old binder. So it's probably not P.
Yeah,
What is PO62? So PO62, we have three concepts. One we learned yesterday, or the last 2 days, the one we're learning today, and PO62 that we're learning tomorrow. Okay? And we're using past objectives to help us with that, especially with the variables on both sides. We know how to do SADMER. So we're going to be using that. So let's look at what this means. When combining like terms, you are only working with one side of an equation. You do not use opposite operations until you go to the opposite side of the equal side. When you move terms to the other side to isolate the variable. So when it's on the same side of the equal sign, you do the same operations. When you are moving something to the opposite side of the equal sign, that's when we do opposite operations. So if we're not moving to the opposite side, we do the same operation. Same side, same operation. So let's do some together. And we are going to show your work. You are not doing mental math. Okay? We are showing our work. So, like terms, 6x plus 4x would be what? 10x. And that equals 50, right? So now we want to solve for x. What is x? What do I do? Maddie. How do I get the x by itself? So I want to divide 10 from both sides. 10 divided by 10 gets me down to my x. 50 divided by 10 gives me 5. Christian.
Why do we divide it by both sides? Like, why can't we just divide it by 50?
Because if I'm only dividing by 50, then I'm saying it's 10x equals 50. Or, sorry, 10x equals 5. I have to divide both sides so I get the x by itself. So I have to divide 10 divided by 10 so I get my 1x. Okay? So when I say divide it by both sides, it's so I can get my variable by itself. So it's 1x. Let's look at our next one. Combining like terms. What's negative 8x plus 5x? Lauren? Negative 3x. And that equals negative 12. I want to get x by itself. What do I have to do, Jude?
Divide negative 12 by negative 3. Or divide both sides by negative 3.
Divide both sides by negative 3. Negative 3 divided by negative 3 gives me that positive 1. So I know it's just x, and I want it to be positive. So I have to make sure I'm dividing by negative. What is negative 12 divided by negative 3, Grayson? 4. Positive 4. Negative divided by a negative is positive. Let's look at 18n minus 10n plus 2. If I combine like terms, what is my equation going to be, Grace? Keep going. Yes. So I combined my n's. 18n minus 10n gave me 8n plus 2 equals 90. Notice how I rewrote my equation, keeping in that plus 2. I have my plus 2. Now I want to solve for x. We need to think back to the two-step equations we did. What's my next step I'm going to do? Henry?
Is it going to get the n by itself?
Nope. Not getting n by itself yet. Because remember, I have to do SADMER. So what does the SA stand for? Subtract and add. So what do I have to do first? I'm not worried about the 8 because the 8 is multiplied. 8n is 8 times n. I want to look to see where I have adding or subtracting. And remember, if I'm going to the opposite side of the equal sign, I have to do opposite operation. Lucas,
Let's go. 90 minus 2. Get 80.
I'm not just subtracting 90 minus 2.
Oh, you're also doing 2.
I'm also subtracting 2 from this side. I have to subtract from both sides.
And then,
So 8n,
8n.
2 minus 2 equals 90 minus 2, which is 88.
And you divide them both by 8.
Then I want to get my n by itself. So I have to divide both sides by 8 because I had been multiplying by 8. 88 divided by 8 equals 11. Let's look at our next one. 7 plus 10n plus 3 minus 2n equals 2. So when we have lots of terms, the first thing I want to do is figure out what I'm combining. I have my variable of n's, and I have my constants. So I draw my lines so I keep track of what I'm combining so I don't miss combining something. Remembering that I have to have the operation with that term. It's not a 2, it's a minus 2. So what would my new equation be when I combine like terms? Grayson?
Is it 10 plus 8n?
No.
10 minus
Oh.
8n?
I had it backwards because I always do the variable first.
Oh.
So you are correct. It would be, I've got the 10n minus 2n gives that 8n that Grayson had said. And then 7 plus 3 is the plus 10. So yes, I had it flipped. It doesn't matter which way it goes. So in my head, I was thinking the 8n. So when you said 10, I got thrown. And that equals our 2. So now we're on to our two-step equations, which was a few objectives ago. How do I solve it? Kaylin?
You subtract 10 from 10 and 10 from 2.
I'm going to subtract 10 from both sides. So what am I left with, Kaylin?
You're left with 8n equals -8.
Yes. 2 minus 10 is a -8. We need to remember that negative sign. Now what do I do, Olivia?
You divide 8 from both sides.
I'm dividing 8 from both sides. 8 divided by 8 gives me 1n. -8 divided by 8 gives me what, Kate?
Oh, -1.
-1. I knew you knew it because I heard you whispering it. So, how are we feeling about this? We're combining, doing yesterday's objective, combining like terms, and then we're doing our two-step operations. Remember, opposite operations. First, you add or subtract, opposite of what the equation was telling us. Then you multiply or divide, opposite of what the operation was telling us. Do negative signs matter?
Yes.
A lot.
No.
I see.
A lot. So, we have another thing, another part that goes with it, that distributive property. Remember, we talked about the distributive property in the last objective. The goal of that distributive property, when we did A times B, A times C. So remember, that is when we had A outside the parentheses, B and C. And I did this, meaning we had to multiply the A through to both terms. Still have people only multiplying to the first term. Multiply it to both terms. What do you think the goal is for that? What are we trying to take away?
The n?
Nope. Remember, we're taking away those parentheses. So the goal is to eliminate parentheses.
That's Eli mate.
Eli mate.
There's an in there, don't you see it?
Oh yeah.
Eliminate.
Oh, yeah.
So, remembering the distributive property, when we have PERMDAS, what is the P stand for? Parentheses. Yesterday's assignment, I had people adding and then multiplying through the parentheses. You do not add parentheses first. If we want to take care of the parentheses, you have to multiply first. If there is something in front, if we had a D in front, plus, we don't do D plus A. Adding is way at the end. Do not add first. You do the parentheses first. If we're eliminating the parentheses, you do that first. So distributive property first, because that's multiplying through the parentheses. You have to do that before you add or subtract a term that was in front. Some of us were still adding or subtracting that term in front. So remember, distribute the coefficients to everything in parentheses and multiply, don't add. You're multiplying it through. Pay attention to your signs. If it is a minus A, you're multiplying in a negative number. Pay attention to those signs. Think if I'm multiplying a negative by a negative C, it turns positive. Pay attention to the signs. Let's do some work together. 7 times the n minus 5 equals 42. What do I do, Madden?
So you multiply 7 times n, which gets you 7n, and then you do 7 times negative 5, which gets you negative 35. So it's 7n minus 35 equals 42.
Perfect.
And then you do 42 plus 35 to get 77.
What?
And then you divide.
Oh, hold on. I still have minus 35 here. Remember, you have to add to both sides to get rid of that 35. So now it's 7n equals 77.
And then you divide 7 by 7 to get n1, and then you divide 7 by
77 by 7.
which gets you n equals 1.
So the first thing we do is the parentheses, then we do our opposite operations. Who can walk me through the next one? Claire G. Oh, negative 6 what?
Oh, and
Do not forget variables. I had a lot of people forgetting variables on yesterday's worksheet. You have to include the variable.
3 times 9 to get 37.
I'm sorry, to get what?
Oh, 27.
Uh-huh. And is it positive or negative?
Positive 3 to add.
Okay.
Equals 39. And then you have to minus 27 from 27 and from 39.
So I get negative 6x, 27 subtracted by 27, zeros out. What is 39 minus 27? What's my next step, Claire?
Then you have to divide by negative 6.
Both sides divide by negative 6. Negative 6 divided by negative 6 leaves me with a positive x. What is 12 divided by negative 6? Negative 2. Notice how as I'm writing it, I'm keeping it all on top of each other. My equal signs are all lining up. So I'm keeping track of my work. I guarantee you, as you get into higher level math and you have many, many steps, you don't want to be doing your steps all over your paper. You get confused as to where you're at and what you're doing. Organize your work as you work through it. Who can walk me through my next one?
Oh, please.
Shh, James.
So you do 8 times 1n gives you 8n then you multiply 8 times -5, which gets you -40,
Mm-hmm.
and then you add 2.
Yep, so I'm bringing down the rest of my equation. So I'm rewriting that rest of the equation once I did my distributive property. So now I know it's 2 plus 8n minus 40 equals 122. And James was saying, hey, wait, we've got some more combining to do, right, James? What can I combine now?
The 2 and -40,
Which becomes what?
-38.
2 minus 40 is a minus 38, and that equals 122. So now what's my next step, Fiona? Oh, you're stretching. Lucas,
Add 22 is 38 and 3 122.
I'm sorry, say that one more time for me.
Add 38 to -38 and 122.
Okay, so I'm adding 38, so minus 38 plus 38 zeros out. So I have 8n, 122 plus 38 is 160. So now how do I get n by itself? Damien,
You divide by 8 to both sides.
divide both sides by 8. So 8 divided by 8 is my 1n. 160 divided by 8 is 20. How can I check to see if I did my math correctly, Grace? Yeah, I can go back and I can put 20 in for my n in the original problem and see if I get 122 when I do all that math. So on the test, do you think it's a good idea to check your work?
Yes.
Yeah. So when you get your variable, go back and plug that answer in and see if it equals it. Does it turn into 122? So check your work, because that will catch us doing those simple mistakes. Oops, I forgot a negative sign. Okay, it will catch those for you if you're checking your work. Let's do the last one. Kaylin, you haven't done one yet, right?
Oh, wait, I did one of this.
You did one on the top. Thank you for being honest. Who has not done one? Matthew. Grayson. No. We have to go quick.
Okay, negative 3 starts with, you do -3 times 8, and you get -24n. And then you -3 times -1, and you get 3.
Positive 3, so it's plus 3.
So plus 3. And you just bring down your equation, so it's 3 and minus 24, and then, just bring down the rest of your equation.
Equals 3.
Yep, and then you do combine you do 3n plus -24.
Oh, plus negative 24,
Yeah.
which would be 3 and minus 24.
And you get negative, so you rewrite it as -21
Yeah.
and plus 3 equals 3. And then you do minus 3, just cancel out that 3, and then you do it to the other 3.
Mm-hmm.
Oh wait, yeah, and then you get -21 and
Equals what?
0.
Okay.
And then you do plus 21.
Nope. What math am I doing? Negative 21n. What operation is it? Divide by negative 21. Divide by negative 21. So I get n equals what, Grayson?
0.
If I put 0 back in the original, 8 times n is 0. 0 minus 1 is -1. -1 times -3 is -3. -1 times -3 is 3. 3 times 0 is 0. 3 equals 3. So you can get a variable that equals 0. So you would plug in 0 in for your n's. -3 times -1 is a positive 3, which equals a positive 3. Let's look at our second page.
Check answers.
So, solve each equation for the variable, show your work, and that you checked your answer. Actually plug your variable in that you get for your answer. Make sure you didn't make those simple mistakes. So you're going to show me that what your variable for x is, plug it in, and I should see 77 equals 70. Should you just write 77 equals 77? No, you should do the math. So whatever you get for x, you're going to show it to me. So what that would look like, 5x plus 2x is 7x equals 77. Divide by 7, and I get x equals 11. So I'm going to plug that 11 in and say 5 times 11 plus 2 times 11 equals 77. So this is 55 plus 22 equals 77. And I'm showing that 77 really does equal 77. That is showing your work and checking your answer. I circled my answer so I know where it is in that whole mess of writing. Olivia?
Oh, do we have to put that as for when we check our work on the test? Like, would it be wrong if we?
Well, it depends on what the directions say. If the directions say show your work and that you've checked your answer, yeah. Should we show our work on the test? Yes, absolutely. I do expect you to show your work on the test. I do not want to just see answers. Okay, so show your work, but checking your answer that on the test, if it says to check your answer, then I need to see it. If it doesn't say it, then I don't. On the homework, what we learned yesterday was we need to check our answers. Any questions on today's assignment? We've got 8 problems to do. So that's it. I did one of them. You're doing the other 8. If you have questions, make sure you come and see me. I will be passing out yesterday's worksheet for you to correct those mistakes also. So if you are watching this at home, I hope you are well, and I hope to see you soon. Have a wonderful day.